Hello guys, this is Prime Concept. In this video, I want to consider a very important aspect of the conic section. We have introduced the conic section in our previous videos. We've talked about what a conic section is by definition. We've looked at the different shapes that forms what we know as the conic section. We mentioned that the shapes that forms the conic section would include the circle, would include the ellipse, would include parabola and then hyperbola. These are the major shapes we want to consider. So in this video, we're going to look solely into the ellipses. Look at the shape of an ellipse, the diagram of an ellipse, or the sketch of an ellipse. We're going to look at the definition of an ellipse, the mathematical relationship, and the different terms that are associated with the ellipse that can help us to sketch an ellipse, right? Now, first, we have mentioned that generally a conic section is actually a point that moves such that there is a constant ratio between the distance from that point to the focus and the distance from that point to the directrix. That is what a conic section is by definition. So that when that constant ratio, which we mentioned, that the constant ratio is known as eccentricity. So let me quickly repeat. The eccentricity is actually what defines a conic section. So it means that eccentricity is the ratio of PF to the ratio PA. That's to say, if I have a diagram like this, and then this is a line from a conic, this line is known as directrix. Directrix. That's what this line is. We defined that in our previous video. We gave explanation to different terms that are used. So a directrix is a line, right? Now, if we have some fixed point around here, and this fixed point, we said it is known as focus. It doesn't change for a particular conic, say ellipses, it doesn't change, it remains fixed. So we have a fixed point and we have a fixed line. We can pick any random point, let's call it point P, such that we can measure the distance from point P to the focus as this. We can also measure the distance from point P to a point on the directrix, right? And we'll call this point A. The eccentricity of the conic is defined as the ratio between the distance PF to the distance PA. Now, for this conic to represent an ellipse, it simply means that the eccentricity E should be less than 1. So the definition for an ellipse is that a point moves such that the constant ratio is always less than what? 1. So E here represents eccentricity. So this you're seeing here is actually the major definition for an ellipse. So for an ellipse, you take note of the fact that the eccentricity is less than 1. So what does it mean? It means that the eccentricity should be values like 0.5, 0.2, 0.3, 0.004, and so on, but it should have values that are less than 1. So that is an ellipse. Now, what is the shape of an ellipse? So I'm quickly going to give the shape of an ellipse, since we are considering ellipse. Now, we can draw an ellipse in two different ways. So one of them is like this. And draw my ellipse. An ellipse just has a form or a shape similar to the shape of an egg, right? Now I can draw my ellipse in this form. Of course, we know that this is our x-axis, positive x-axis, and these are negative x-axis, right? These are positive y, and these are negative y. Now you would notice something from this ellipse, even though it's not drawn to scale. But you would notice that the length of the ellipse from the center to this point on the x-axis and to this point on the x is longer or is greater than the length to the y-axis. So when you have your ellipse in this form, such that the length along the x-axis is greater than the length along the y-axis, it means that the major axis of your ellipse is the x-axis. So for this particular case, our major axis is the x-axis. So the major axis of this ellipse is what? The x-axis. So we usually label this ellipse such that the minor axis takes the value b. So this is minus b, and this is going to be plus a. The major axis takes the value a. This is going to be minus a. So this is the ellipse, right? Now the next thing we want to learn, I'm going to give the equation for an ellipse where the major axis is the x-axis. I will draw the diagram for an ellipse where the major axis is the y-axis, and then I'll give the diagrams. I will point out some other things we need to know about the ellipse. So for this case, the equation of this ellipse would be given as x minus h all squared divided by a squared plus y minus k all squared divided by b squared equals 1. So this is the equation of an ellipse where the major axis is the x-axis. Now one of the things you would have observed there is that if your major axis is your x-axis, it means that the value that should be under your x in this equation should be a. So you would see how this differs from the other. So let me draw the other elliptical shape. So we have something like this, then we have in this form. So we have like this. Now in this case, you will notice that the length along the y-axis is longer than the length along the x-axis, right? Yes. So that when we want to label this, remember the longer length is always where you label with a, with the value a. So I'll call this positive a, negative a, call this negative b, and positive b. So this is how, so what it means is that for this particular ellipse, your major axis is your y-axis, while your minor axis is your what? X-axis. So major axis is the x, is the y-axis, sorry, is the y-axis for this particular ellipse. Now what would be the equation when the major axis is your y-axis? It will be written as x, x minus h all squared divided by b squared plus y minus k all squared divided by a squared equals 1. So you now notice that since our major axis in this case is the y-axis, then a, the value a, is under your y, while in this case the value a is under our what? B. So we should take note of these diagrams and relationship. Now something else I want to point out from these equations is that an ellipse would also have a center. Yes, and they want you to find the center of an ellipse. It's very simple, just like you can see. They want you to find the center. The center will just be gotten by equating what you have in the square of x and in the square of y. You equate them to 0. Then that would give you the center of your ellipse. So let me rub this and make do with this for now. So I would have that for me to obtain the center of my ellipse, given this equation, I would simply say that x minus h is equal to 0, and then x becomes h. I'll do the same thing for y. I'll say y minus k equals 0, which would mean that y is equal to k. So the center of my ellipse is given by the coordinates h, k. So this is how we can always find the center of our conic. Now somebody may ask, if you are given an equation for an ellipse and you are asked to determine which axis is the major axis, how do you do that? It's very simple. When you are given an equation for an ellipse, for you to tell which axis is the major axis, you check where the bigger denominator lies. Does it lie under your x or under your y? Let me illustrate what I mean. Say we have an equation x minus 2 all squared divided by, let's say, 9, then plus y minus 3 all squared divided by 4. This is equal to 1. Now, for this particular question, we want to get the center of this ellipse, and we want to also find which axis is the major axis. Then if we get that, we'll determine the value of A and the value of B, assuming that is what we want to do here. First, we want to find the center. Now, to find the center of this ellipse, it's very simple. To determine the center, what do? I would simply notice that this should be equated to 0. So I would have x minus 2 should be 0, so that I would say x is 2. If I do same thing, I would have y minus 3 is 0, so that I would say y is what? 3. And the center of my ellipse is going to take values. Center of this ellipse would now take values of, you write the x first, 2 comma what? 3. So this is the center of this ellipse. Now, if I should ask you which axis of this ellipse is your major axis, now quickly we're going to check. We have 9 and we have 4. Which of these values is larger? Of course, you can see that 9 is bigger than 4. So what it simply means is that the x-axis is the major axis. So this would be your diagram for that conic. The x-axis is our what? Major axis. Now, if you want to get the value of A, what do? Very simple. You want to find the value of A, and then you want to also find the value of B. What you would quickly do is to recall that the equation of this ellipse, the standard form will be x minus h all squared divided by a squared plus y minus k all squared divided by what? B squared. This is equal to 1. So I'm going to now equate a squared to 9. So I would say that a squared is equal to 9, which would now mean that a is the square root of 9, and then a becomes what? 3, for taking the positive value. If I do the same, I want to find b, I would say b squared is equal to 4, so that b squared becomes 4, which would imply that b is square root of 4. I'm taking the positive value, so b is equal to what? 2. So the values of a and b respectively are 3 and what? 2. So you can see that a, which is 3, is bigger than b. So it means that the major axis of this ellipse is what? Is the x-axis. So I believe this is clear to us. Now, something else you want to know for an ellipse. We have mentioned the equation of an ellipse. We have mentioned the center of an ellipse, how you can find the center. Now, there is something else you can always be required to find, how to find the focus of an ellipse. Remember, we mentioned in our previous video that the focus is a fixed point on a conic, right? That point does not change. Once you draw that ellipse, the point would remain fixed, right? Now, and we said that for an ellipse has two focus. It's just like saying an ellipse, if you divide it into 3, it would have like 2 centers. That is what it means. If I divide this shape into 3 equal parts, I would have dividing one part from here, dividing one part from here. So you see that it's divided into 3 parts, right? So this first point we have located is what we call our focus. I'm calling this F1, and this point is what? F2. So an ellipse would always have 2 focus. How do you find the value of that focus? Now you notice, if we are considering the x-axis as the major axis, then our focus is going to be, our x-axis is major, so it's going to be plus or minus AE and 0, since along the x-axis the y value is what? 0, right? So this is our focus when the major axis is your what? X-axis. So please do not mix it. If the major axis is your y-axis, so let me write major axis is x. If your y-axis is major, then your focus will change. Focus would now become 0, plus or minus AE. Major axis is y. So in this case, this is what you have. So do not mix it, because along the y-axis, x would be 0. So that is why this would be true. So, but for this diagram, the focus is given by this y plus or minus, because your focus 1 lies along the x, negative x, 1 lies along the positive x. So this is one thing you should know. Another thing we should take note of is also what we know as the vertex. Remember, we defined the vertex of a conic as the for an ellipse. We said it is the point where the ellipse touches the major axis. That is your vertex. So you can see, where does this ellipse touch the major axis? Is at this point, which is called point what? Positive A, and at this point, which is point negative A. So the vertex of our ellipse, considering the x-axis as the major axis, is going to be plus or minus A and then 0. This is the vertex. The major axis is x. So this is what you would have under this condition. If your major axis is the y-axis, of course, I believe you know what it will be. So you would have our vertex is going to be 0 plus or minus A. Major axis is y. So this is what we have for this second case. Please do well to take note of these relationships. I've given you the equation of an ellipse. I've told you how to find the center of an ellipse. I've told you how to find focus. I've told you how to find vertex. The next thing I want to mention is how to determine the eccentricity of an ellipse. You want to find the eccentricity. Remember, we mentioned that the eccentricity is actually the quantity that determines which type of conic you have, right? For an ellipse, the eccentricity should always be less than 1, right? Yes. For a circle, just a bonus, eccentricity will be what? 0. We can prove that anyway after this. Now, how do we find the eccentricity for an ellipse? You take note of the equation b square equals a square into 1 minus e square. So with this equation, we can always determine the value of eccentricity for a conic. I can decide to make e the subject, right? Yes, but then there's no point. I think once you can remember this equation, it's easier to remember in this form than to make e the subject. So this is how we can find eccentricity, right? And the next thing I want to also mention is how we can find the directrix. Remember, we said the directrix is a line that is perpendicular, usually perpendicular to the axis or to the major axis of the conic. So for this particular ellipse, where our major axis is the x-axis, our eccentricity is going to be a line like this. It's going to be a line like this. You can see that this line is perpendicular to the major axis. So this is our eccentricity. We'll also have another one here. This is our eccentricity, right? So how do we find this eccentricity? The eccentricity is given as x equals plus or minus a over e. So this is how we can find the equation or the point of this eccentricity. So plus means for this first one, which is on the positive side. Minus means for this other line, which is on the negative side. And this is when your x-axis is the major. If the reverse becomes the case, we would say y equals plus or minus a over e. Now, what is the next thing we want to get? Remember, this is the equation for directrix. This is the equation for directrix. Major axis is x. So this is the equation you would have, right? Now, then, the final thing I want to mention before we take an example that would help us is how you can find the latus rectum. Now, what is the latus rectum? Let me write it. latus rectum. What is the latus rectum? We've defined it already, but let me still mention. The latus rectum is a line that passes through the focus, and that line is perpendicular to the major axis, right? And then the end point of that line touches the conic. So this is my focus. I'll draw a line which is perpendicular to the major axis. The end point of this line is on my conic. So this is the end point. So this straight line you can see is my latus rectum. So it means I would have two of it. So I have another one here. So this line you can see, these two straight lines are what we refer to as latus rectum. So if our major axis is the x-axis, what will be the equation for the latus rectum? The equation for the latus rectum is simply going to be 2b squared all divided by a. Your major axis is what? X. So this is what you would have for the equation of latus rectum. If the major axis is the y-axis, my latus rectum equation becomes 2a squared over b. So in this case, my major axis is what? The y-axis. So I believe that all these things are clear to you. So very quickly, I'm going to take one very important example that would sum up all these things. All right, so we'll be taking this example to explain the concept of the ellipse, but there will be a little addition to this problem that would also help us understand the ellipse very well. Now, I gave us equations, or I gave us formulas for finding focus, vertex, and so on. We considered a simple case where our ellipse lies on the origin. So this one is going to explain in more details if our ellipse deviates or shifts away from the origin. So it will be helpful to us. Now this problem says find the coordinates of the center of the ellipse, which is this. Also determine these parameters: the vertex, the eccentricity, the focus, and the directrix. So we want to find these parameters. But first, you will notice that our ellipse is not given in standard form. So it means that the first thing we want to do is to be able to write this ellipse in the standard form. So to be able to do that, you would really understand the concept of completing the square. So I'll be using that concept here to solve this problem. So do well to follow so you get it well. So I'm going to write 4x squared. I'm going to bring the x's together. So 4x squared minus 16x plus 3y squared plus 6y. I'll push this 7 to the other side. It becomes minus 7. So the first thing when you're completing the square is that the coefficient of x squared, the coefficient of y squared should be 1. So in order to achieve that, I'm going to simply do 4 into x squared minus 16x, 4 into x squared minus 4x minus 4x. This is so that when you multiply this times this, you would get back this. This multiply this, you would get back this, right? Now, if I factorize this also, I would have plus 3 into y squared plus 2y. Then this should be equal to negative 7. Now, quickly, we want to apply the completing the square method to this. By completing the square, what it means is that you take half of the coefficient of x, then add it to this, and then add it to the constant. But I'm not going to add to the constant. I'm going to subtract from this. So watch so that you get what I'm going to do. So I'll have 4 into x. Half of 4 is actually 2. So I'll have minus 2 all squared. Now, why do I have minus? Because there's a minus here. Now, I would repeat. Half of 4 is actually, half of negative 4 is 2, negative 2. When you square negative 2, it becomes 4. So I'm subtracting 4 from this. And plus 3. You have to solve this problem the way I'm solving it so you don't make mistake. Remember, some persons may decide to take 4 to this side. And when you do that, you would have lost this 4 outside it. I should multiply this. So go in this sequence, I'm solving it. Now, if I do the same here, half of 2 is 1. So I'm going to say y plus 1. Why is it going to be plus? Because this is plus. Then I would repeat, half of 2 is 1. 1 squared is 1. So I'm subtracting 1 from this. So this is equal to negative 7. Right? Now the next thing I want to do is to expand with this 4. So I'll have 4 into x minus 2 all squared. 4 times this is minus 16. Then plus 3 by this is 3 into y plus 1 all squared. 3 by this is minus 3 equals negative 7. So the next thing, I want to push all these constants to the other side. So I'll be left with 4 into x minus 2 squared plus 3 into y plus 1 squared equals negative 7. And when this negative 16 crosses, it becomes plus 16. When this crosses, it becomes plus 3. So I would have 4 into x minus 2 plus 3 into y plus 1 all squared. Now this should be equal to, this is 16 plus 3 is 19. 19 minus 7 is 12. So I have 12. Now one of the things you should know for an ellipse is that the right hand side of an ellipse should always be equal to 1. So that equation will be in standard form, right? Yes. So in order for me to make this right hand side to be 1, I'm going to divide all through this equation by 12. So I'll have 4 into x minus 2 all squared. I'll divide this by 12 plus 3 into y plus 1 all squared. I'll divide this by 12. Then I'll say 12 divided by 12. Now when you do this, you notice that 4 can reduce this to 3. 3 can reduce this to 4. This would go to give 1. So I'll be left with x minus 2 all squared divided by 3 plus y plus 1 all squared divided by 4. All this is equal to 1. So I've succeeded in writing this equation for an ellipse in standard form, leaving this place to be what? 1, and saying that this is positive. So quickly, for me to find the center of this ellipse, and you will notice, of course, seeing this, it shows that this ellipse does not have the center at the origin. So it will shift from the origin. So for me to find the center of this ellipse, it's going to be x minus 2 equals 0, and then x is equal to 2. I'll do the same. Y plus 1 equals 0. Y is equal to negative 1. So the center is going to be 2 comma negative 1. So this is the center of my ellipse, which is the very first thing they want us to get. And the next thing I want to find is my value for A and the value for B, so that we can then use that to get our vertex and so on. Now, I know that, okay, in order to do those other things, I need to find A and B, right? Like I've mentioned. Now, remember, we said the major axis of our ellipse is going to be determined by the value that is bigger. So between 3 and 4, which of them is bigger? Of course, 4 is bigger. So it means that the major axis of our ellipse is what? The y-axis. So my A is going to come from here. So I will quickly say that A squared is equal to 4, which is this, so that A becomes square root of 4, which is what? 2. I'm taking just the positive value. Then same way, I would say B squared is equal to 3, which would mean that B is equal to what now? The square root of what? 3, right? Of course, I just wrote the positive value, but we're going to need the 2 of them later on. But for now, let's go with this. So I have my A, I have my B. So I want to quickly find my vertex. So that is the first thing, my vertex. Now, please take note of the fact that our ellipse does not lie on the origin. So it deviates from that by a value given by the center. So our vertex, rather than being 0 on the x and then plus or minus A on the y, is going to shift by the values of the center. Remember, this is h and this is k. So it means that my vertex, since we have a center that is not the origin, is going to be h, comma, k plus or minus a. So this is now going to be the vertex. So it's very simple. Since it is not at the origin, then it's starting from the center, which is h. So it's simple to get. Now, what is my h? My h is 2, and my k is what? Minus 1 plus or minus, what is my a? My a is 2. So this is what I have, so that I quickly say that my vertex is 2, comma, this is going to be, if I do the first, okay, minus 1 plus 2 is going to be 1. So I have 1, or 2, comma, minus 1 minus 2 is going to be minus 3. So this is my possible vertex, 2, comma, 1, or 2, comma, minus 3. So that is my vertex. And the next thing I want to get is my directrix. Sorry, my eccentricity. I hope that is what they asked next. My eccentricity. So in order for me to get my eccentricity, I recall that b squared is equal to a squared into 1 minus e squared. So with this, I can get my eccentricity. So knowing that b squared is actually equal to 3, so I would write 3, and we know that a squared is equal to 4, so I would write 4 into 1 minus e squared. So if I have that, I can rub this side. So I would have 3. Now what I'll quickly do, I'll divide both sides by 4, so that I will have 3 divided by 4, which would be left with 1 minus e squared. So if I bring e squared to this side, I'll have that e squared is 1 minus 3 divided by 4. This would imply that e squared is equal to, now you say 4 times 1 is 4, 4 minus 3 is 1, so I'll say 1 divided by 4. So that e becomes square root of 1 divided by 4, which is 1 over 4. Of course, I can still say plus or minus, because I'll still need it. So e is plus or minus 1 over 4. 1 over 2, because square root of 4 is 2. So this is my eccentricity. So I've been able to get that. Now the next thing I want to get, number 3, is my focus. Again, our focus is still going to shift from the origin. So remember, our major axis is the y-axis. Assuming we were at the origin, our focus is going to be 0, comma, plus or minus AE. But since we are shifting from the origin by the center, by the value given by the center, it means that our focus now, instead of starting from 0, is going to be h, and then comma is going to be k plus or minus AE. So this is what my focus is going to be. So how do I find this? I know h, I know k, right? So I'll quickly write that my value for h is 2, comma, my value for k is minus 1 plus or minus, what is a? A is 2, so 2 times my e is 1 over 2. So this is what I have. So I have 2, comma, minus 1 plus or minus, this would go, you have 1, right? Yes. Now if I should write, I can leave my answer like this, but let me still put it in a better way. If I should write this, so my focus is going to be 2, comma, if I say minus 1 plus 1 is going to be 0. So this is my first focus, or I would say 2, I'll repeat this, 2, comma, I would say minus 1, which is minus 2. So this is my focus, or this point is my focus. Now, what's the last thing they want us to get? The directrix. The directrix, IV. Directrix. The directrix, let me see. Okay, the directrix, I was thinking is something as the axe. So the directrix is also the same thing, going to shift. So our directrix, we said, assuming that, okay, our directrix is going to be our major axis is the x-axis. So it's going to be our major axis, sorry, is the y-axis. So it's going to be along the y. So it's going to be y, which is equal to plus or minus a over e. This is what it should be, assuming we're working from the origin. But since we are not working from the origin, then our directrix should be y equals k plus or minus a over e. So this is what it should be from that value on the y-axis. So I believe if I leave this, you should be able to finish this and drop the answer in the comment section. So before I finish it, pause the video and drop your answer to the directrix in the comment section. Then come back and confirm your answer. So y is k, and our k is minus 1 plus or minus a, which is 2 divided by eccentricity, which is 1 over 2. So my directrix equation is minus 1 plus or minus 4, because these two will come up, right? So I have y, which is equal to minus 1 plus 4 is actually going to be 3, or my directrix becomes minus 1 minus 4. It's going to be minus 5. So this is the equation of my directrix. So if you actually want to sketch this ellipse, it will be very simple to sketch. I've rubbed most of my values because of my small board. But say we want to sketch this, I'll just give a rough sketch. We have this. So say we want to sketch, remember the center is no longer the origin, and then the major axis is the y-axis. Our center is 2 comma minus 1. So let's say this place is 2, and let's say this place is negative 1. So it means that the center is going to be somewhere here. So my ellipse is going to be like this. It's going to be somewhat like this. Of course, I'm not drawing to scale. So it's going to be somewhat like this, so that this is the center. And the coordinates of this center is 2 comma minus 1. So this is the center of my ellipse. So the focus is somewhere around here and somewhere around here. So I can call this F1, call this F2. So this is my focus. And then my directrix is going to be like this and like this. My directrix, which has values of negative 5. This is negative 5. Then it has value of 3. This is 3. So this is the equation of my directrix. This is my directrix. What else are we supposed to get? Okay, we have the focus. Then we have our vertex. I can't remember the value, but this is our vertex. Trace this. This is your vertex. The value you have here is our vertex, right? So this is a rough sketch for this ellipse. Now, if you have followed this video up till this point and you are yet to subscribe, it means you may not see my next video, which would be on parabola. So do well to subscribe to my channel, so that when I post next video updating you on parabola and solving more problems here, then you will be one of the first to be notified. So do well to subscribe, like this video, comment, and share with 10 of your friends. Tell them this is Prime Concept. Thanks for watching.